So I'll get started. Good afternoon, everybody. Unless you're on the West Coast, then good morning. My name is Brendan Kerrigan. I'm a principal engineer at AIS Incorporated, and I'm going to talk to you today about vglass and give you an introduction to the project and a roadmap that we'll be kind of moving towards in the future. There we go. A little background on the project itself. It evolved from a few earlier iterations of display backends for client virtualization over the years. Pre-2012, we were using Surfman for a downstream project that was on Zen Client XT at the time. And then in 2012, we came out with Multiview, which was a separate display domain that was used in combination with Surfman. Essentially, Multiview allowed multiple domains to have seamless window composition in a separate domain, so that you could go ahead and have kind of windows from one Windows guest look like it was a single unified desktop. In 2013, we came out with Display Handler, which essentially allowed us to do multi-monitor. Surfman itself can only handle doing single display, so we kind of came up with a design to go ahead and extend that to multiple displays across multiple guests. We presented this at Zen Summit in 2016. We were getting ready to open source it, and then we got kind of mired in some regulations. So in 2017, we kind of went back to the drawing board because we wanted to get it open sourced and did a clean room implementation of Display Handler with the same features and capabilities. And then we kind of got mired in the same type of red tape. Finally, we got through the red tape in 2020, so here we are. We'll be having it open at the end of the presentation. So what is vglass? vglass stands for Virtual Graphics Layer and Supporting Software. It's a display and input solution for client virtualization, and it includes a driver set that supports QEMU StubDOM, Linux DRM driver, Linux FBDev driver, and a WDDM driver for Windows 10. So some of the components of vglass. So there's glass, which is the actual display and input backend binary. And there's a couple of subcomponents of that are distributed across some shared libraries. PV Display Helper is a cross-platform protocol shim for PV displays. So this we kind of came out with back in 2013. So it was predated Display IF. So we kind of have this custom intermediary protocol in there right now. IVC is a server client abstraction that we use on grants and event channels, which is essentially kind of like a V2V design, where as opposed to like V4V or Arco. SVDRM is a Linux DRM driver for our guests. OpenXTFB is a Linux FB driver for guests that only supports a single display. Zen WDDM DoD is the Windows 10 driver for graphics. Disman does display configuration management, so we just make sure that if a user is configuring their displays and they have them overlapping or something like that, that we come out with a close enough but same configuration to prevent kind of the overlap between displays or gaps between displays, which would cause some input issues. And Meta vglass is a Yocto OE layer to kind of bring all these components together, and that's kind of build. So some features. Left we have kind of some of the play features, and on the right have features. We have multi-monitors on Windows Linux guests. Share all display all guests, or allocate a subset to a given guest. So say you want your Windows guests to have 2 monitors, you can have that, and then allocate another monitor to just your Linux guests, so that's always up. So there's a lot of flexibility there as far as configuring how you want your display set up. And we have configurations that we've tested that support up to 10 displays if you have GPU pass-through, but generally I would say 4 is what we normally would be the high end. We have seamless mousing between those pinned guests, so if you dedicate a display to a particular guest, you can kind of mouse in and out based on whatever geometry you set up in the UI. We have support for added guest overlays to display system information. So say you have a time zone or a time, battery information, and perhaps a label of what VM you're currently in at the time. So it also handles input multiplexing. We do have multi-touch that goes all the way to the guest. We do have experimental pen input that's being worked, and we do hot plugging support for both input devices and for monitors. All right. So some of the architecture, at least from the system perspective, we have a graphics domain. Usually for us, that's going to be DOM0, but it's possible to move it out of there depending on if you can get your graphics card successfully passed through to another domain. So we have Zen on the bottom. We have our kernel space. vglass talks to the physical GPU using DRM. vglass has a bunch of components inside of it that go ahead and talk to either the QEMU stub DOM, or it can bypass the stub DOM and the emulation and go directly to these PV drivers that are up here. And it also does support plain old PV guests and PVH guests. So that's the system architecture. As far as the software itself, Glass is split up into essentially 4 main components. We have a window manager that kind of controls geometry information, and it essentially tells the renderer component where to put the pixels from wherever they come from in the guest to where they belong on the screen. So you can see here the guest graphics driver is a source for the renderer, and there's also overlays. The window manager tells the renderer how to combine those and put those out onto, say, the DRM device that's attached to it. You can also output to, say, VNC, which we do use for kind of testing. So we can have automated testing kind of go about the UI without having to have someone sit there and do it. The tool stack kind of provides just some VM lifecycle information, if a new VM's coming up, set up resources and all the other modules. And it also provides like some meta information. So say the VM name, or maybe some extra information, like if you have a label for it or what color you would want its icons to be and stuff like that. And then on the right side, we have the input server, and essentially it's going to pull input events from the Linux subsystem, or if you have an additional source that you want to add, it's a pretty easy interface to add stuff into there. So like we have a file replay interface so that you can record events from an input device to a binary file and then play them back. Goes through a set of filters. So say you wanted to switch VMs and we want to have a hotkey for that. We'll check to see that the input at this point, do we want to, say, change the focus of the VM that's in place right now and getting input. We can do that here, and various other things that anywhere you'd want to kind of tap the input before it gets multiplexed out to a guest. So it syncs here. Essentially, it's how are you going to communicate that information to a guest? Right now we have 2 different syncs, one that talks to QEMU over kind of a custom channel, and then we have another that talks just KBDIF. Eventually the plan is to just settle on KBDIF and use that as the sole sync. Okay. All right, so I have a video demonstration. Let me see if I can get this right. Let me know if you guys can see this. Okay. All right, just walk you through what's going on here. Pulling up the configuration panel. I've configured my monitors down the 3 blocks on that screen, just like the geometry of my actual guest or my monitor setup. And then I went and clicked into this rel VM that I have, and it's up on the 3 monitors, and I can move windows about the different monitors as if it's just a regular desktop. You can see I got my /dot up there. Then I'm going to go hit Control Tab, and that'll get me back to the UI VM with the Zen Panda. And then I'm heading over to my Windows VM, because Control Tab is kind of a hotkey to switch VMs, and you can see that I've got a Windows VM up, and you can interact with it just like you normally would. And then I'm going to go down. You can see that I have the Microsoft Maps open. That is a touchscreen laptop, so I'm going to start interacting with the map with the multi-touch. I don't have a pen device, so I couldn't demonstrate that. But you can see it's pretty fluid. I'm going to try to head to the conference and find Romania. And there we go. One thing I didn't mention there, if you see on the top, there's these kind of overlays, and that's some of that meta information that I was talking about the tool stack is providing. So essentially, each of my VMs has a name, like my RHEL VM has a label as development VM, and I have my Windows VM is labeled as a corporate VM. Okay. So the roadmap is pretty informal at this point, but there's some components that we want to deprecate. PB Display Helper, while it served us pretty well in the past, it makes sense, I think, for us to go ahead and replace that with Display IF. There's a well-known upstream protocol. We should just use that and remove some of the custom components that we don't necessarily need. If we replace Display IF, IVC itself falls away too. So we can kind of just use grants and like the dev grant tab and dev event chan, as opposed to having a whole stack of things that we need to maintain and don't need to be there anymore. SVDRM, so that's our custom add a kernel DRM driver. We'd hope to basically move to Zen DRM front so that we can not have to ship a separate driver that needs to be installed and fool with DKMS and all that stuff. OpenXT FB, at this point, I think we just deprecate and use either SVDRM or Zen DRM front, depending on at what point in time we are in that process of moving to DRM front. Some work to do. So that Zen WDDM DoD driver, that needs to be ported from Display Helper protocol to Display IF. So that's going to take some doing, but I don't think it'll be too bad. The protocols are not wildly different. It's kind of only so many ways you can design a protocol to pass that information around. Meta vglass is a little bit of a mess at the moment, so we're going to work on cleaning that up. So that's ongoing. I'd like to move from libzen backend, which is a project that was part of OpenXT, to libzen BE. Libzen backend is not really maintained very much, and libzen BE from the Zen Troops folks seems to be maintained pretty well. So I'd like to move our KBDIF sync in the input server over to libzen BE. Currently, the only tool stack plugin that we have is basically implementing the tool stack interface is for Zen Manager on OpenXT. So we're looking to add one for the red control tool stack. So I think that'll be coming pretty soon. Being that a lot of this was designed around working with OpenXT, there's a lot of dbus stuff that's sprinkled around that really needs to be unified and pushed back into the tool stack interface. So that cleanup would be nice to get done sooner rather than later. And then the other thing is that we do have the two renderers right now, and we have some other experimental renderers that are not really in the tree because they've kind of bit rotted, like a GL renderer, and we did have ZenGT support way back when it worked well with the local buffers on Zen. But currently you can only have one renderer in use at a time. So when I was talking about the VNC rendering, we have like a separate kind of copy-pasted code base to support DRM rendering and VNC rendering. I like to get that separated out so that you can just kind of have a list of renderers that will go and do what they have to do. So you could use the DRM rendering and the VNC rendering simultaneously without having to kind of mash code together. And the reason that we do that is essentially for some hot plug testing and automated testing of we can attach to the device with VNC, but actually get the display layout from the actual graphics cards that sit in there. And potentially, if you have like an EDID faker or something like that, you don't even need real displays in order to do it. So that's essentially the roadmap that we have. We've had a lot of contributors over the years, so just a thanks to all these folks. They've put a lot of hard work into it over the years and have added a lot of features and bug fixes and stuff like that. So thanks to everyone listed. And from there, I'll just take questions. Yeah, Rich, as far as the changes and the way that GPUs are handled over the years, I think that the design is pretty resilient to those changes and kind of adapting to them pretty quickly. I think that's one of the changes that when we went from display handler, we kind of corrected some of the design issues that we came up with at that time. So we definitely have the ability to add different kind of sources and sinks for rendering. Kind of an example of that would be using VNC as a graphics sink. And when we had the support in there for ZenGT, we were able to kind of have 3D going into the guests. We do have some ongoing work that we should be able to publish once it's finished, excuse me, to basically provide the ability to do 3D acceleration in guests with some of those kind of MX GPU, SRIOV type devices and NVIDIA devices and stuff like that. So that work's ongoing. I'm not sure where that particularly will land, but the design itself should be pretty easy to adapt to changes in the GPU market. Have our drivers gone through WHQL? No, they have not. That's something that I think that hopefully once we get moved over to DisplayIF, we can kind of upstream those to the WinPV project, and then as a whole have that whole driver set go through WHQL. Yeah, so the driver that we use in Windows for multi-touch is ZenHID, but we do the kind of the back-end piece of that for the multi-touch, translating it. So what's not kind of shown in that video is that, so that's kind of our most basic window manager. We do have an internal window manager for a customer that we can open source that provides kind of windows for your VMs, and you can drag VMs around like it's their applications. And the multi-touch support for that works as well. So if it's in a window, we can kind of do the translations necessary to forward that over to ZenHID, and it makes sense from a user perspective. Yeah, so virtual 3D and OpenGL remoting we've kind of looked at over the years, and I think that that's something we could certainly add as a renderer source. So right now, the only renderer source that we have is really that PV display helper protocol, and then like the next step would be to add the display IF one. But there's nothing to say that we couldn't add something like virtual 3D and OpenGL remoting as separate syncs to be used. And being that the window manager itself doesn't really know anything about the implementation of those syncs, you can still have whatever compositor you wrote, and it should work just fine. The renderer will just put the pixels in whatever format they need to be in the right spaces geometrically. So you would just get 3D in the composition of whatever compositor you have kind of for free. You wouldn't have to rewrite anything in your window manager. Currently, there's a lot of manual regression, and that's a piece of why that VNC combined renderer was added, so that we can kind of have a controller that logs in over VNC, and then we'll go ahead and start performing the regression testing. So we have the framework in place. As with testing, kind of get the test. We have the ability to hook in there and do the test. We have to work with expanding the test set available. We do have some unit tests that are kind of around the Zen Manager tool piece, but as far as some work to do is adding units for the other plugin. Thank you. Yes, and I did forget to add a slide with URLs, so I wrote them over here. But it's gitlab.com/vglass, and then I just kind of plugged gitlab.com/redfield, which is our kind of base client virtualization, distribution, and then infosec.com/beam, which is a product that we're working on. Alrighty. If nobody has any other questions. That's interesting. Oh, it's vglass with no dash. And it's GitLab, not GitHub. Okay, yeah, I might have to tweak some of the permissions on the organization itself. I know I made the organization public, but I might not have gone to every subrepo. So I will take care of that afterwards. Let me just write that down. Yep, no problem. All right, I don't know when the end time for this was scheduled, but oh, right there, right on the dot. There we go. So thanks everybody for listening. I hope you enjoyed it, and hopefully this is a useful project for people out there. All right, have a good one.